In this video, I'm going to show you how we can write the form of a particular solution for a non-homogeneous differential equation. First, we discuss about the case that the right side of the non-homogeneous differential equation is sine or cosine function. For example, consider this second order non-homogeneous differential equation. 3 sine of x plus 7 cosine 2x. We know that the general solution y is the sum of complementary solution and the particular solution. And here complementary solution is the solution that we can find from the corresponding homogeneous differential equation to this differential equation. So, for finding y complementary, we have to find y from this homogeneous differential equation. But the y particular is the part of the solution that is related to the right side of the equation. But first, we have to find the complementary solution. If you don't know how to find y, the y complementary, watch my video about solving homogeneous differential equations. For solving this homogeneous differential equation, first we write the characteristic equation. R squared, because we have double prime, so r to the 2 plus 4 equal 0. This is the characteristic equation for this second order differential equation. For finding r here, you can use quadratic formula, or actually it is easier to move 4 to the other side, so r squared is negative 4. If we take a square root, r is plus minus a square root of negative 4. But note that a square root of negative 4 is a square root of 4 times a square root of negative 1. Square root of 4 is 2 and the square root of negative 1 is I. So this equals to plus minus 2i. And we can suppose here we have 0. So the root of the characteristic equation is 0 plus minus 2i. So we have two complex roots. And when we have complex roots in general in the form of a plus minus bi, if you remember from solving homogeneous differential equations, the solution of the differential equation is e to the ax, a is the number here, which in this case is 0, c sub 1 cosine bx plus c sub 2 sine of bx. So if we use this formula for this question, y complementary is e to the 0x, because a is 0, times by c sub 1 cosine 2x plus c sub 2 sine of 2x. E to the 0 is 1, so we can write our complementary solution in the form of c1 cosine 2x plus c2 sine 2x. So this is the complementary solution. Now let's see what is the particular solution. The particular solution for this differential equation is actually two-part, because note that here we have 3 sine of x and 7 cosine 2x. Because the angles of the trig functions are different, one of them is x, the other one is 2x, we cannot write one function for both of them. Again, because here is x and here is 2x. So, for writing the particular solution, we have to consider these parts from this part separately. So, for a moment, suppose we don't have this function here. Focus on this part. Here we have 3 sine of x, and we want to write the particular solution for 3 sine of x. the function or functions that second derivative of them plus the same function equals 3 sine of x is only sine and cosine, because we know that by taking derivative of sine and cosine we can back to the same function. So because we have a trig function sine of x here, the form of the particular solution is a sine of x plus b cosine of x. Note that it doesn't matter only here we have sine of x. Whenever you have sine or cosine of an angle, you have to put both of them, both of sine and cosine, in the form of the particular solution. And a and b here are the unknowns. Note that here we want to solve the differential equation with the undetermined coefficient. So we have a and b as unknowns. But for the other part of this equation, now look at this. Because we have cosine of 2x, so we have to add two terms for that. C cosine of 2x, d sine of 2x. And note that it doesn't matter to put cosine or sine first. It's up to you to put sine or cosine. But you have to put both of them again in the particular solution. Maybe you think this is the form of the particular solution. But note that always when you write the particular solution, check the terms in the particular solution with the terms in the complementary solution. We know that none of the terms in the particular solution should be duplicated in the complementary solution. Sine of x and cosine of x is not appeared here, but cosine of 2x and sine of 2x, we have them here. So these two are duplicated in the complementary solution. And we know that this should not happen. So this is not the correct form for the particular solution. How we can solve this, how we can get rid of this problem? Always when a term or terms duplicates in the complementary solution, you can solve this issue with multiplying those terms by x or other degrees, higher degrees of x. But here x is enough. If we multiply this by x, now we have x cosine 2x and x sine of 2x. And we don't have any x cosine 2x and x sine 2x here. So this is the form of the particular solution for this differential equation. Now let's move to the next case. The other case is when we have a differential equation. Actually, this is the fourth case. The other side of the equation is the product or multiplication of exponential functions by a trig function. By trig we mean sine or cosine. For example, consider this differential equation: y double prime minus 4y prime plus 5y equals e to the negative x sine of 3x plus e to the 2x cosine x. The general solution, as usual, is the sum of complementary and the particular solution. First, we have to find complementary solution by solving the homogeneous differential equation. Y double prime minus 4y prime plus 5y equals 0. The corresponding characteristic equation for this differential equation is r squared minus 4r plus 5 equals 0. If you try to factor this, you can see that you cannot factor this. So use another method for finding r. For example, you can use the quadratic formula. R equals to Remember the quadratic formula, negative b plus minus b squared minus 4ac over 2a. B here is negative 4, so negative b is 4 plus minus a square root of b squared, 16 minus 4 times a is 1, 4 times 1 is 4 times 5, 20, over 2a, a is 1, so 2 times 1 is 2. 16 minus 20 is negative 4, and the square root of negative 4 is the square root of 4 times the square root of negative 1, and this is 2i. So we can write r as 4 plus minus 2i over 2. If we divide 4 by 2, it equals 2, and if we divide 2i by 2, we have I. So plus minus I. These are the complex roots of this characteristic equation. And so the complementary solution is e to the ax, 2x, times by c sub 1 cosine of coefficient of I here is 1. We have 1i, so cosine of 1x plus c sub 2 sine of x. If you don't know how to write the complementary solution, watch my video about solving homogeneous differential equations. So this is the complementary solution for this equation. Now we can write the form of the particular solution. Y particular, similar to the previous example, is two-part, because we have this function and this function. These are two different functions. The y particular for this part is a e to the negative x sine of 3x plus b e to the negative x cosine 3x. These two functions are the functions that by taking the derivative of them, it is possible to produce this. So in the writing the particular solution, we put both of them. It doesn't matter we have only sine here. Always we have, when we have sine or cosine in our non-homogeneous differential equation, when we write the particular solution, we have to put both of sine and cosine function in the particular solution. And similarly, for this part, the y particular for that is c e to the 2x cosine of x or sine of x, it doesn't matter which order you put them, plus d e to the 2x cosine x. Now if we compare the term in our particular solution with the terms in complementary solution, we can see that some of the terms in the particular solution are repeated in the complementary solution. These two terms, e to the negative x sine of 3x and e to the negative x cosine of 3x, is not repeated here. So this part of the particular solution is correct, but because e to the 2x sine of x and e to the 2x cosine of x is repeated here, because if you multiply this in the bracket, we have e to the 2x cosine x and e to the 2x sine of x. So because these are repeated in the complementary solution, we have to multiply this part by x. Multiplying by x prevents the duplication. We know that we have to multiply. When duplication happens, we have to multiply by a degree of x that prevents the duplication, and always we choose the smallest degree, smallest positive degree, and here x to the 1 is enough. So this is the particular solution for this differential equation. Note that our focus in this video is not in finding the unknown coefficients a, b, c, and d. If you want to learn how we can find these unknown videos, watch my other videos. Here in these videos, our focus is in writing just the form of the particular solution. And this is the form of the particular solution. But if you want to find a, b, c, d, you have to go ahead and find y prime and y double prime, the first and second derivative of this big function, which is really complicated. Plug in here and set it equal to this, then you can find a, b, c, d. I hope by watching this video you have learned a bit about writing the form of the particular solution for non-homogeneous differential equations. If you like this video, please subscribe in my channel.